This is America in Space, a weekly news and information program on current events dealing with the space industry.
Welcome, and thanks for joining me today. I'm Dawn Meyer, Space Coast News Editor. On September 22, 2022, NASA and SpaceX signed an unfunded Space Act agreement to study the feasibility of a SpaceX and Polaris program idea to boost the Hubble Space Telescope into a higher orbit using the Dragon spacecraft at no cost to the government. The study is designed to help the agency understand commercial possibilities before deciding to move forward with the mission. SpaceX, in partnership with the Polaris program, proposed this study to better understand the technical challenges associated with servicing missions. Since the study is non-exclusive, other companies may propose similar studies with different rockets or spacecraft as their model. The study is expected to take up to 6 months, collecting technical data from both Hubble and the SpaceX Dragon spacecraft to help determine whether it would be possible to safely rendezvous, dock, and move the telescope into a higher, more stable orbit to extend its life. Alpha Tech describes more details of the study and proposal.
Referring to the Hubble Space Telescope, people will definitely remember a workhorse cosmic observatory for astronomers around the world since its launch in 1990. It has been dazzling with dramatic stellar imagery and enabled important discoveries such as the age of the universe and the moons of Pluto. NASA believes the Hubble remains highly productive until at least the late 2020s or 2030s. However, many components of the telescope have spent decades in an unforgiving environment of space, raising unsurprising concerns about their longevity. More importantly, the inexorable march of time, gravity, and Earth's atmosphere means Hubble is guaranteed to eventually re-enter that atmosphere and burn up without intervention. That terrible demise could come as early as the mid-2030s. However, the story is about to change as NASA and SpaceX just officially announced a plan to boost Hubble Telescope's orbit with Dragon. So how will this happen, and is it really feasible? NASA and SpaceX have recently signed a Space Act agreement to conduct a 6-month study to determine the practicability of Dragon docking with the 32-year-old telescope and boosting it into higher orbit. The study's not exclusive, meaning other companies can propose similar concepts with alternative rockets and spacecraft. NASA and SpaceX will spend the next 6 or so months discussing whether it's possible to use Dragon to boost the telescope's orbit back to a nominal 600 kilometers or around 372 miles. Both parties say that the agreement would also investigate the possibility of Dragon servicing missions, which could be even more significant for Hubble. While a boost that large would likely keep it in orbit for decades to come, there's no guarantee the telescope would remain functional to take full advantage of the extra time it would have. During the 5th and final Space Shuttle servicing mission, NASA astronauts installed a docking adapter soft capture mechanism on the Hubble telescope. Although no concrete plan exists for any additional servicing missions, the forward-facing installation of that adapter has made the feasibility study possible. In theory, that docking adapter could make boosting Hubble's orbit far more feasible, safe, and affordable than a shuttle-style crew servicing mission. SpaceX's Cargo Dragon 2 spacecraft has the same autonomous docking capability its crewed sibling has and costs less to launch and operate. So it's not inconceivable that an uncrewed Dragon could autonomously dock with Hubble and boost its orbit. Jessica Jensen, SpaceX's VP of Customer Operations and Integration, says an uncrewed option will be studied alongside crewed servicing and orbit boost alternatives. According to Patrick Krause, NASA's Hubble Space Telescope project manager, without a reboost, NASA would need to consider a separate mission to ensure a controlled deorbit of the massive telescope by the end of the decade. The study's targeted boost of 40 to 70 kilometers, meanwhile, could extend the longevity of Hubble's orbit by 15 to 20 years or well into the 2050s. But as a feasibility study, there's a chance that it will conclude that using Dragon, crewed or uncrewed, to boost serviced HST isn't feasible. Ordinarily, the most likely outcome would be a conclusion that the project is feasible from a technical perspective, but out of reach from a financial perspective. This is when we enter billionaire and private astronaut Jared Isaacman, who was directly involved in the September 29th press conference. The agreement comes after SpaceX and the Polaris program, a series of private missions self-funded by billionaire Jared Isaacman, approached NASA about potential servicing missions, including the Hubble Space Telescope. Isaacman is the first private citizen to command an orbital spaceflight when he led a crew of 4 aboard SpaceX's Dragon, and that was in 2021 on the Inspiration 4 mission. With Polaris, he's seeking to push the boundaries of private space exploration outward. When asked about the synergies between Polaris program, SpaceX, and NASA, Isaacman revealed that he and SpaceX are willing to undertake a 6th Hubble servicing mission, more or less pro bono, with little or no potential cost to the government. According to Isaacman, it's possible that the study could result in a Hubble servicing mission becoming the 2nd Polaris program mission.
As the Hubble continues to be used, often in coordination with the James Webb Space Telescope, it will be interesting to see how the SpaceX proposal plays out. Thank you for joining me. Remember each Tuesday to join David Denault for America's Return to Space, and join me every Friday for America in Space. From the Florida Space Coast, I'm Dawn Meyer, Space Coast News Editor for About Space Today.
Thanks for listening. Be sure to share our program with your family and friends and follow us on Facebook. Join us each week for news and information on America in Space.